Section 4.3 is on trigonometric functions of angles. To begin with, what happens if we're not on the unit circle, meaning my radius is something other than 1? Well, I must satisfy the equation x squared plus y squared equals r squared. Or in other words, my radius must be equal to the square root of x squared plus y squared. And of course, my radius must be greater than 0. So the following must be true for my 6 trigonometric functions. Sine theta is equal to y over r. Cosine theta is equal to x over r. Tangent theta is y over x, where x cannot be equal to 0. Cosecant theta is r over y, where y cannot be equal to 0. Secant theta is r over x, where x cannot be equal to 0. And cotangent theta is equal to x over y, where y cannot be equal to 0. Now, I don't suggest you memorize the 6 trigonometric functions when the radius is 1, meaning on the unit circle, and these 6 trigonometric functions when the radius is something other than 1. If you're going to memorize any formulas, it would be these 6 in this section 4.3, because this will work if my radius is 1 or something else. So kind of just memorize the standard formulas with radius r. Let's take a look at an example. Suppose theta is an angle whose terminal side contains the point 1, negative 2. Find the exact values of the 6 trigonometric functions of theta. You'll notice in the paragraph I did not mention the phrase, this point on the unit circle, right? I didn't mention unit circle anywhere, so that's a hint that this point is probably not on the unit circle. So, to verify either way, to do a double check, it can't hurt. Again, I must satisfy the equation x squared plus y squared equals r squared. So, r is equal to square root of x squared plus y squared. I went ahead and plugged in my values, 1 and negative 2, and I simplified and got my radius as square root of 5. And now I'm going to go ahead and find the 6 trig functions. So sine theta, y over r, so that would be the y value, negative 2, over radius, square root 5. Remember, I cannot leave a square root in the denominator of a fraction, so I need to rationalize the fraction by multiplying top and bottom by square root 5. And so my sine theta is equal to negative 2 square roots of 5 over 5. And then I did cosine theta, x over r, so that's 1 over square root 5. After rationalizing, I get square root 5 over 5. Tangent theta, y over x, so that's negative 2 over 1, which simplifies to negative 2. Cosecant theta, r over y, so that's square root 5 over negative 2. Nothing to rationalize there, and so you're done with that one. Secant theta, r over x, so that's square root 5 over 1, which is just square root 5. And cotangent theta is x over y, so that's 1 over negative 2. Again, nothing to simplify on that one. The next thing we need to learn is the signs of the trigonometric functions. How do we determine what quadrant an angle lies in? So remember, the quadrants are numbered, so we have quadrants 1, 2, 3, and 4. Remember, cosine and sine represent your x and y value. So in quadrant 1, cosine is positive and sine is positive. In quadrant 2, cosine is negative, sine is positive. In quadrant 3, cosine is negative and sine is negative. In quadrant 4, cosine is positive and sine is negative. So let's take a look at an example. If tangent theta is greater than 0 and cosine theta is less than 0, which quadrant does theta lie in? So if tangent theta is greater than 0, that means tangent must be positive. Well, tangent represents y over x. So I could get that with both y and x being positive. A positive divided by a positive is positive. Or x and y can both be negative, right? Because a negative divided by a negative is also a positive. Well, tangent being positive happens in quadrant 1 or 3. The second piece of information told me cosine theta must be less than 0. Well, that means cosine must be negative. Well, cosine is negative in quadrant 2 or 3. Well, if both of these things must be true, they overlap when I said quadrant 3. So 3 is my solution. Next, the reference angle. The reference angle for theta is the acute angle theta prime, and it is formed by the terminal side theta and the x-axis. So if we're in quadrant 1, our theta and our theta prime are the same. If my angle is in quadrant 2, then theta prime, my reference angle, is the remaining distance it takes me to get to the x-axis, theta prime. If I'm in quadrant 3, then my reference angle is from the x-axis to that angle, theta prime. And if I'm in quadrant 4, the reference angle is the distance it takes to continue again until you hit that x-axis. So let's look at an example. Let's find the reference angle for theta is 200 degrees. So 200 degrees lies in quadrant 3. So the reference angle is that distance from the x-axis to the angle. And so to calculate that, I just need to remove 180 degrees. So that's going to be 200 minus 180, and that distance, our angle, is 20 degrees. There are 3 Pythagorean identities to take note of. I go into more details on these 3 a little bit later in this semester, but for now you can jot these down. Cosine squared plus sine squared is 1, 1 plus tangent squared is secant squared, and 1 plus cotangent squared is cosecant squared. Even odd functions next. Your 2 even functions are cosine and secant. Remember, cosine of negative x is equal to cosine x, and secant negative x is equal to secant x. And the remaining are considered odd functions. So sine of negative x is negative sine x. Tangent negative x is equal to negative tangent x. Cosecant negative x is equal to negative cosecant x, and cotangent negative x is negative cotangent x.